and welcome to today's crash course on the mechanical properties of materials. This video is a secondary 3 video, but if you're in secondary 4, it could also be relevant to you. You just have to remember that when you are dealing with materials and their constraints, in secondary 4, you need to justify your choice of choosing those materials. So if you remember, in part 1, if you've seen it, we talked about the 5 different constraints of materials as well as the effects of those constraints, so the types of deformations. In today's video, we're going to talk about the mechanical properties of materials. So there are 7 mechanical properties of materials that we're going to explore in today's video. But first, we should talk about what a mechanical property is. So a mechanical property of a material describes how the material behaves in response to one or more constraints. And we have 7 ones that we're going to explore. So we have stiffness, resilience, fragility, hardness, elasticity, malleability, and ductility. So let's jump right in with a question. What material is the best choice for the frame of a tennis racket? Is it A, metal, aluminum, B, ceramic, C, particle board, or D, composite material, also known as carbon fiber? The answer is D, composite material. So let's think of the characteristics of a tennis racket. It needs to be fairly stiff to withhold the impact of a tennis ball. And also it needs to be resilient. So it needs to withstand that force. So if we think about metal, metal is quite resilient, but aluminum is not very stiff, right? It can bend. And so it won't necessarily absorb the impact like it should for when a tennis ball hits the racket. If we look at ceramic, it's stiff, right? That's why we like those ceramic things, but it also can break really easily. So it's fragile. It's not resilient. If we have particle board is a kind of material that's more on the cheap side. So it is not exactly stiff or resilient. It can withstand some force, but it is not the most ideal substance or material to use. And lastly, we have our composite material, which is both stiff and resilient, that carbon fiber. And so it can withstand those hits from that tennis ball. So obviously the better choice. So in the last question, I mentioned a couple of mechanical properties, and so we're going to explore them more in detail. The first one being stiffness. And stiffness is the ability of material to resist deformation. Now, whenever we're dealing with mechanical properties of materials, we can ask ourselves a question. This one, we can ask ourselves, does it bend easily? So in our first example, you see we have yellow chairs. Those yellow chairs are made out of a certain type of plastic, and it is considered to be stiff. It doesn't bend easily. So it's not going to bend in on itself when we sit down. It's not going to collapse. If we talk about, for example, aluminum, this aluminum can, it is not stiff. It bends easily. It will not be able to resist deformation. The next mechanical property that was mentioned in the question was resilience. And resilience is the ability of material to resist shocks. So again, we have a question we can ask ourselves. Does it break easily? Most toys, like we see here, if you drop them on the ground, they won't break because most plastics are quite resilient. They're not going to break on impact. They can resist that force. Then we also have a ceramic vase. Now we know ceramics can break quite easily. So if they fall on the ground, they're going to shatter into a bunch of different pieces. So in this case, our toys are resilient. They don't break easily. And our ceramic vase is not resilient. It's also called fragile, which is the opposite of resilience. So if it's not resilient, it is called fragile. Oftentimes, stiffness and resilience can get kind of confusing. So here's a table to help you out with the difference between the two. So we have fishing line, and fishing line, as you can see, is wrapped around the spool, and it can bend quite easily. So it is not considered to be stiff. But as we know, fishing line is meant to reel in really big fish, just like little itty bitty fish. And so it is not supposed to break easily either. So it is quite resilient. If we look at our glass straws here, glass does not bend easily. That's the whole point of glass. But we know that it is not very resilient. If you were to drop a glass straw or glass vase on the ground, it would break very easily. So glass is not very resilient. I hope this helps. Our next mechanical property that we're going to be exploring is fragility. And fragility or brittleness is the ability of the material to break without deforming. So we ask ourselves yet another question. Remember also that I forgot to mention, fragility is the opposite of resilience, right? So if something's resilient, it could withstand force. If something's fragile, we ask ourselves, does it break easily? So perfect example, we have our phone here. It is fragile. When you drop your phone on the ground, the glass part of the screen can shatter if you don't have a case around it, which is why we have phone cases that are usually made out of plastic, and they are resilient, which means they're going to protect that phone from being broken or shattered, that glass of breaking. So again, when we have something that is fragile, it will break easily. Our next mechanical property is hardness. And hardness is the ability of materials to resist abrasions or indentations. So we ask ourselves, does it scratch easily? And so when something is considered hard, like for example, a granite countertop or a marble countertop, over the years and years and years that you might have that countertop, it resists scratches and indentations, and it still looks new. It is considered hard. A diamond is also considered hard. It doesn't scratch or chip easily. If you have a wooden cutting board, though, for example, it's considered not to be as hard. It's considered actually soft because, as you can see, it doesn't matter if you cut on that cutting board as often as you possibly can. It scratches easily. It doesn't look new. So it is considered to be less hard or not hard. Let's do a practice question. True or false? Ceramic is stiff, fragile, and hard. The answer is true. Let's set ourselves up with some guiding questions. Does it bend easily? No, it does not. It's considered a stiff material. Does it break easily? Yes, it is not resilient. And does it scratch easily? No. That's why it's a popular choice for flooring. So, stiffness, fragility, hardness, it's true. Our next property that we're going to talk about is elasticity. Elasticity is the ability of the material to deform and return to its original shape. So again, we're going to ask ourselves a guiding question. Does it return to its original shape on its own? And that's really, really important, the on its own part. So if we take the example of an athletic rubber synthetic band, okay, so you're doing that with your stretching or a muscular exercise. When you let go of that band, it will return to its original shape on its own. So it's considered to be elastic. However, if we take an example like Play-Doh is easy to move and to maneuver and to compress and to stretch, but it will not return to its original shape on its own. Therefore, it is not considered to be elastic. So the last two properties that we're going to be talking about are properties that have to do with metals and alloys only. And the first one that we're going to talk about is malleability. It's the ability of a metal or an alloy to be flattened or bent without breaking, and it retains its new shape. So aluminum is a great example. It's a metal that can be flattened and bent and made into tinfoil. It can also be stretched and bent to make cutlery and plates. So it is a perfect example of something that is malleable. And finally, our last property, which is ductility. And that is the ability of a metal or an alloy to be stretched without breaking. So metals like copper and aluminum, they can be stretched into certain electrical wire, steel wool. So they are considered to be extremely ductile. Let's try a secondary 4 question. If you're in secondary 3, consider it a challenge question. What mechanical properties justify the choice of aluminum for the manufacture of a spring? Is it A, ductility and elasticity, B, ductility and malleability, C, malleability and elasticity, or D, malleability and fragility? The answer is B, ductility and malleability. So let's go through the mechanical properties of aluminum one by one. So if we think about metals like aluminum, I mentioned in the mechanical properties that there are two that are specifically meant for metals, and that is ductility and malleability. So in order to make this spring, this aluminum spring, you have to be able to stretch it, and then you have to be able to bend it into that shape of a spring. So it is both ductile and it is malleable. However, I want you to remember there's one thing that's really important. For elasticity, okay, elasticity has to do with the material and not the object. So remember that question that we said, is it able to go back to its original form on its own? And if we think about the aluminum spring, the property of aluminum is that it cannot go back to its original shape on its own. So it is not elastic. And finally, we hope that a spring on a trampoline or any type of spring is not fragile because it's meant to withstand certain forces. So it is not fragile. So there you have it, our 7 mechanical properties of materials, all listed here. Just keep in mind that some of them are exact opposites of each other. So elasticity is the exact opposite of ductility, remember stretchability, and malleability, which is bendability. And then you also have fragility, which is the opposite of resilience. So just keep those in mind when you're studying for your next test. And if you haven't seen part 1 yet, I suggest you go have a look.